Greetings students. In last session we have studied about wave motion and sound, the basics, introduction about wave, definition of wave, classification of wave, and in classification we have studied about two types of classification. First, based on the medium requirement, and as per that classification we have classified wave into two parts, mechanical and non-mechanical. And depending on the direction of vibration of medium particle, we have classified waves as transfer waves and longitudinal waves. Today we will do the detailed study about those classifications. Let's start with that. We have classification of waves. Classification wave. A as per the requirement of medium. Okay, depending on medium requirement. So the classification, first classification is mechanical. We'll do the detailed study. Those waves which need a material medium like solid, liquid or gas for their propagation are called mechanical wave or elastic wave. So mechanical wave are the wave that need a material medium The example of material medium is like solid, liquid or gas. For their propagation. Few important points about these waves. First, mechanical or elastic wave. These waves also known as elastic. Cannot travel through vacuum. They need material medium. Example of these waves: sound waves in air, water wave, wave on the surface of a liquid, wave produced in a stretch string. Next, wave produced in a spring. These are the few examples of mechanical wave. We'll explain that in detail. See, all gradually as we proceed, the explanation will come automatically. But over here, just to give you an overview, if I am dropping a pebble in the water, still water, you will see the water surface, and that will not be remain still. Okay, that will not remain still. You will find a concentric circular waves mostly getting produced in water. Mostly these we can observe in any kind of, and these waves easily to be noticed. This is a wave produced on the surface of water, and if we put a small leaf on that surface, we can see that leaf going up and down along its mean position. That will give us explanation that these waves are mechanical in nature as well as transverse. So we'll study about transverse when we come to that. So right now, just to understand that water waves creating on the surface of water, and that is example of mechanical wave. And if I have a string like in guitar, the wave which will be produced in this system, that is example of mechanical wave. These are the example of mechanical wave. Now second we have non-mechanical and electromagnetic wave. Non-mechanical electromagnetic wave. These waves do not need a material medium for their propagation. These waves don't need a material medium The important points about these waves are these waves can even travel through vacuum. Example of electromagnetic wave. Example, radio waves, infrared wave, light, visible wave, visible light waves. We all know about light, infrared and radio waves. These are the waves does not require any medium to propagate. Now we will study about the difference between mechanical and elastic wave. Difference between mechanical and electromagnetic wave. We'll point out main difference. The elastic wave or mechanical wave, we'll point out these difference, see it clearly. The difference, first difference, the mechanical wave are due to the vibration of the particles of medium through which they pass. Whereas electromagnetic wave are due to the varying electric and magnetic fields in space. This is the main difference. The next difference, elastic wave have a low speed. On the other hand, the electromagnetic wave have a very high speed, that is approx 5 into 10 to the power 8 meter per second in vacuum. The next difference, elastic wave or mechanical wave have usually low frequency and large wavelength. Low frequency and large wavelength. On the other hand, these waves, that is electromagnetic, have very high frequency and extremely low wavelength, low, or you can say short. I would like to point out over here, you know the Planck formula, E is equal to h mu. The h is Planck constant, mu is frequency. So if a wave is having very high frequency, that means it will be having a high energy, it will contain high energy. More frequency, more energy. Okay, so mostly electromagnetic waves are the waves which carrying very high energy comparatively elastic waves. The next difference, the elastic waves can be transverse or can be longitudinal in nature. But electromagnetic waves are only transverse in nature. Transverse wave. In next session, we'll study about the classification of the waves on the basis of vibration of medium particles, that is transverse waves and longitudinal waves. We'll study about these things in detail. Okay. Thank you.